by looking at 4.1. So we're only going to do 2 sections in chapter 4. We're going to do 4.1 and we're going to do 4.4. 4.1 is exponents, which is important for college algebra, and 4.4 is working with polynomials. So we'll be looking at those 2 sections, and then we'll be looking at factoring after that, factoring and multiplying polynomials. So let's go ahead and begin with exponents. We're going to do a quick review of exponents. And the rules that are associated with exponents. Okay, so we're going to begin by looking at exponents here. Claudia, did you want to take your exam? Looking at 4.1, again, we're not covering chapter 3 because it's not really part of our outcomes and objectives. So we're going to look at 4.1, and we're going to be looking at exponents. Now, when we have something like this, a to the x power, the a is the base, and that x, that power, well, that is our exponent. Okay, so we have a base and we have an exponent. Now, how does this work? How does it work if I give you, let's say, 5 cubed? Well, how would you work with this? If I say evaluate out 5 cubed would be 5 times 5 times 5. And 5 times 5 is 25. And 25 times 5, well, that is a 125. Okay? Now, you have to be careful with the negative sign. So let's say I give you negative 2 to the 4th power. Okay? How do we evaluate down negative 2 to the 4th power? Well, we don't have parentheses, so this negative here, it's just going to come along with it. So we write this out then as the negative 2 comes along, and then we have 2 times 2 times 2 times 2, and 2 times 2 is 4, 2 times 2 is 4, and 4 times 4 is then 16, and the negative comes along with it. So all we do is bring the negative along. However, it is not the same as this. Yes, it is. Yeah, this I think you'll find this chapter to be quite a bit easier than the last one. So this is not the same as this. This is different. Now, how is this one different? It looks different, doesn't it? So what about this one? Well, this one, what did I do? Okay, when I worked this one out, on the top one, the negative just came along with it, didn't it? Okay, so the negative just came along. What about this one, though? This one, we've got parentheses, order of operations. We have to write it out and use our parentheses just like this. You're going to get a different answer than the other one. So this is not the same as what we had before, because negative 2 and negative 2 is positive 4. Negative 2 and negative 2 is positive 4, and then that comes out to be 16. And as you can see, these are different, right? Okay, these are not the same. Why are they not the same? Because if there is no parentheses, we just simply bring the negative along with it. Okay, so it just is tacked along in front. If there is parentheses, then what do? We write it out however many times we need to. So this is a 4th power, so we write that out now 4 times. And then we multiply. You can use your calculator, or you can just mentally do it like I did. Okay. So I just wanted to review a little bit about exponents before we start looking at the rules. So now that we've talked a little bit about exponents, now we can look at the rules that are associated with the exponents. And we're going to look at each rule from our textbook, and I'm going to give you an example of the rule with both numbers and letters. So again, we're in 4.1. So we're going to look in our textbook. We're going to talk about the rules. There are many of them. All the rules are on page 285 in your textbook. And we're going to do each rule individually. And then I'm going to give you examples of each rule. So the first one is the product rule. And the product rule says this: a to the m, a to the n is a to the m plus n power. So let's look at a few examples. How about we have x to the 5th, x to the 12th. Okay, now with these, what's going to happen when we multiply? Product means multiply. When we multiply, the exponents add together. So we're looking at x to the 5th and x to the 12th. That's going to be then x to the 5 plus 12 power, which is then x to the 17th power. Okay. Exponents add together. It also works with numbers. How about we have 3 to the 8th times 3 to the 12th. Now we need to have a common base. Like this one, the common base was x. So the x was the base. These have a common base of 3. And then that's going to be 3 to the 8 plus 12 power, which is then 3 to the 20th power. Now we don't break down exponents that are larger than 3 or 4. They're just too big, because if we try to use our calculator, this would go on for a really long time, so we keep it as this. If it's just cubed or to the 4th power, then we can break it down. But this one is just too large. Now, where students make a mistake is they try to put these together and make a common base of 9. And it doesn't have a base of 9. Right? These are the base. Base is 3. Exponents add. So make sure you're careful. It's not going to be 9 here. Base is 3. Quotient rule is dividing. Now, when we talk about multiplying, what happened to the exponents? When we multiply, the exponents add. Okay? So, quotient is divide. So, when we multiply, we add. When we divide, they're going to do what, do you think? What's the opposite of addition? Subtraction, right? So, they're going to subtract. So, when you divide, the exponents then subtract. So, the rule is a to the m over a to the n is a to the m minus n power. Okay, so let's look at some examples here. This is going to be examples of the quotient rule. We'll do one with variables, and then we'll do one with numbers. So how about y to the 9th over y to the 7th? What would we do here? This is the quotient rule. We are dividing. When we divide, we subtract. And that's 9 minus 7. So that comes out to be then y what? Squared. Okay? So when you divide, the exponents then subtract. Yeah, and we'll talk about those here in a minute. Once we learn all the rules, then we'll put them all together. And there are many problems where you have to use the quotient rule and the product rule and several others at the same time. We're going to go through the rules individually first, and then we'll put them all together, because some questions require us to use multiple rules. Now let's try one more. How about 5 to the 3rd over 5 to the negative 2nd power? Well, be careful here. Now, what are we doing? Common base again is 5. We are dividing, so then we have to subtract. Now, when we subtract off a negative, what happens to that? Becomes a positive, so that would then be 5 to the 5th power. And you can leave it as 5 to the 5th power, okay, because 5 to the 5th power is just too large to really break down. Next, we have the zero exponent rule. And this is something that's a little bit different as well. I do what now? Yes, yep, and that's the next rule. Zero exponent rule is the next one, and I'm just following along with our textbook. And you're correct. Zero exponent rule says this: any number or variable raised to the 0 power is 1. Not 0, it is 1. So it doesn't matter what it is. Here's some examples. 9 to the 0 power. Okay, 9 to the 0 power is 1. X squared, y to the 8th, z to the 4th. With parentheses, all raised to the 0 power is going to be what? 1. Okay, so exponents are a little bit different. When you raise something to the 0 power, it becomes 1. Negative exponents, we can rewrite them as a fraction. In many cases, when we work these out, if we have negative exponents, then we can rewrite them as a fraction. Because in many cases, you do not want to have a negative exponent in your answer. And the negative exponent just means you can flip it over. So a to the negative n power is the same thing as 1 over a to the n power. So here's an example. How about 5 to the negative 2nd power? Well, 5 to the negative 2nd power, I would rewrite that as 1 over 5 squared. And 5 squared is pretty small because 5 squared is then what? 25. So what would my final answer then be? For 5 to the negative 2nd, well, it would be 1 over 1. 1 over 25. So negative exponents become a fraction. Let's do another one. What about y to the negative 9th power? Well, y to the negative 9th power, and let's put an x in front, just so we illustrate this fact. Okay, so let's say we have x, y to the negative 9th. Now, that x, it does not have a negative exponent, so it stays on the top. But what about y? Y is what? To the negative 9th power, so that becomes y to the 9th. It is different if we have parentheses. If we have parentheses, then the entire part goes down below. So if you had this, let's say this is going to be different. Let's say you have x, y to the negative 9th like this. Okay, this is going to be different than this one. These are different. Why is this one different? Okay, this one, the x is positive for the power, so it stays on the top. Y goes down below. What about this one? Well, this one, the entire part is raised to the negative 9th power. So I can rewrite that as xy to the 9th power. And then I can actually distribute the 9 through, which we'll learn about in our next rule. And that then becomes 1 over x to the 9th, y to the 9th. Okay, so what we do with parentheses is the entire part goes down below, and then we can distribute our power through. So do you see the difference between these two? Okay, notice the difference. Very important. This is where students get mixed up. These are not the same. Parentheses mean it's the entire part. No parentheses means it's just that one piece that goes down. Now, we do have some power rules to look at as well. And there's several different power rules. We're going to go through some of these just to make sure we know how the powers work. And power rules work with parentheses. And a power rule says a to the m to the nth power is a to the m times n. So now we're going to look at some more complicated examples. Okay, because the power rule is all pretty much the same. You distribute it through. So let's say I give you 5x to the 9th, z to the 4th, p to the 9th, all raised to the 2nd power. So how would we handle this one? Now the power rule says these powers do what? Multiply. So what we're going to do is we're going to distribute through. And these powers are going to multiply. Now this 5, there's no power on it, but it's actually a power of 1. We don't write the 1, but it's understood to be a power of 1. So when I distribute that squared through, that becomes 5 squared. And just think about distributing with multiplication. 2 times 9 makes it x to the 18th power. 2 times 4 makes it then z to the 8th power. And then we have, this is a 4 here. 4 times 2 makes it a p to the 8th power. And that would be your answer. And you could actually break this up if you wanted, because we could reduce it down, because 5 squared is what? 25. So this would be your final finished answer. Okay. So that's going to be our final finished answer there. Let's try another one just to make sure that we see how the rules work. So let's do another example. How about we have 9 z to the minus 4th power, p to the 5th power, quantity cubed. Well, what will we do? Okay, the first thing we do is we distribute through. Now there is a 1 here, so we're going to be distributing through, and we're going to multiply. So that becomes 9 cubed. 3 times a negative 4, well, that becomes a z to the negative 12th power, because they multiply, p to the 15th power. Now, how do we do 9 to the 3rd power? We could write it out, or I'm going to show you how to use your calculator. You're going to either have one of these two types of calculators. You'll either have a calculator like this, and if you have a calculator like this one, you have a YX key. So for this style of calculator, how you would take 9 to the 3rd is you would take 9, and then you have the YX key, 3, and hit the equals key, and that gives you your power. So 9, YX, 3, and then hit your equals key, and that's 729. Now, if you have this other type of calculator, which is the one that most of you have, which looks like this, okay, most of you have this style calculator. It's a little bit different. So let's say you have this style of calculator. How would we use it? Well, for this one, you have a caret key. You don't have a YX key, you have a caret key. So this one would be Y, caret, 3, and the equals key. So 9, caret, 3, and then it equals. And that gives you the 729. So if I break this one down, what does this break down into now? That gives you 729. Now, we cannot have negative exponents. So that p to the 15th, it stays on the top. but this is negative, so it goes down below as e to the 12th. So that would be your final answer there. That used several of the rules put together. Right? We had to use our product rule, our power rule. Okay, and then we use our negative exponent rule to rewrite that, and that's going to be your final finished answer there. Now let's go through some questions that require us to use multiple rules. They're all a little bit different. We are going to go through several of these. They're different, but they use multiple rules. So we'll start off with a fairly straightforward one. Okay, so we're going to try to evaluate this one down. So we want to simplify this down. Now, what we want to do is we want to get rid of our parentheses. And we do that first. And I'll put a 2 here. Let's use a 2 as the power. So this one's got a negative 2. This one's going to be a positive 2 here. So that's going to be a power of 2. So the first thing that we do is we get rid of our parentheses. So what do? With our parentheses, we distribute it through for both of these. And then we'll see what we're left with from there. So let's see what we've got. When I distribute through, remember there's a 1 here, so that's 3 to the first power. So 1 times 2 makes it a 2. So that's going to be a 3 squared there, right? 1 times 2 is 2. And then what about the x? We have minus 2 times 2. That makes it a minus 4. And then we have 6 times 2. That makes it a 12. And then we have a 5 to the negative second power. Then we have an x to the negative 6th power here. And we have a y to the 0 power. Because negative 2 times 0 is what? 0. Now, this is going to require us to use several of the rules put together. So where do we begin? Well, where I would begin is let's begin, and I like to work these over to the side. We'll work out these separately. Let's work with the numbers. Okay, 3 squared. What's 3 squared? 3 squared is 9. So that's going to come down here as 9. And then what about the 5? 5 to the negative second. That's 1 over 5 squared. And then 5 squared is a 25. So where does the 25 go? It goes down below. Why? Because this exponent is what? Negative. Okay, so all I did first was the numbers. 3 squared was 9, so it stays on the top. 5 to the negative second power, I rewrote it. And that becomes then a 25 down below. You don't need the extra 1 because a 9 takes care of it. Now let's look at the x parts. What do we have for the x's? For the x's, we've got an x to the 4th that's negative, and an x to the 6th. It's also negative. Those go together, and they make it x to the negative 10th. Right? Those simply go together. Now, what do we know about x to the negative 10th? We can't have negative exponents. So I would rewrite this as 1 over x to the 10th power. So that means that is going down below. Anytime you have a negative exponent, you rewrite it as a positive and it goes below. Now, what about the y part? We're almost done here. What do we have for the y part? The y part, we've got y to the 12th, y to the 0 power. Now, we can either note that this is 1, or we can just put these together, because 12 plus 0 is still y to the 12th. And so that belongs on the top there. Everything has been combined together. And that's as far as we can go. They do take a little bit of practice to get to the point to where you can simplify them. But again, it's using all those rules. Product, quotient, power rule, negative exponent, zero exponent, they all go together. Let's try a couple more. Well, I give you this one. How about I give you I have you simplify 4 x to the 9th y squared over y to the 5th all raised to the 3rd power times 2. How about x to the negative 3rd y to the 5th, all raised then to the negative 1st power. Okay, so this is what I want you to simplify down. And there's many different ways of working with it. What I usually do is I use the product rule first. And then I look inside and I make sure that I don't have to combine things together. So product quotient rule. If we had product quotient inside of here, I would do that. Now I can do something here. All right, what can I do here? This is division, right? So product quotient rules first. We're going to do parentheses inside. Now, what do we know about these y's? These have the same bases, so they can be simplified down with the quotient rule. So we've got y to the 2nd over y to the 5th. So that becomes then, when we divide, we subtract y to the 2 minus 5 power. So that becomes y to the negative 3rd power. And the x to the 9th still stays there. I usually keep the negative exponents until the very end. I think that's the easiest way to work with these. Nothing can combine together inside of the second. So I'm just going to rewrite it because nothing can be done. So the first thing I did was I saw that these right here can go together. And that gave you then that. Okay. Now we're going to distribute through. And then we'll work with everything that's left over. So let's distribute that 3 through. So that's going to be 4 cubed. Y to the minus 3 times 3 makes it a minus 9 power. X to the 9 times 3, that's 27. And we have a 2 to the negative 1st power. We'll deal with that in a moment. Negative 1 times a negative 3. Negative and negative makes it a positive 3. And then we've got y to the negative 5th power there. Now we can go ahead and break it down a bit. It doesn't matter how you work with it. You just want to work and make progress. I usually like to work with the numbers first. I think that's the easiest thing to do. So we're going to now work with 4. So we've got 4 cubed and 4 cubed. Use your calculator or write it out, one or the other. Let's again review how to use our calculator. 4 cubed would be 4 caret 3. And that gives you 64. So that's going to go here, 64. And what about 2 to the negative 1st power? Well, that's 1 over 2. So we just rewrite it as 1 over 2. And we'll reduce this down in a moment. Now let's look at the x part. And what do we have for the x part here? We have an x to the 27th here, and we have an x cubed here. Those go together with addition, and that makes it an x to the 30th here. Because when we multiply, these powers add. And then we'll look at our y's. So we have a y to the negative 9th, y to the negative 5th. Those go together and make it y to the negative 14th. And what do we know about y to the negative 14th? It's 1 over y to the 14th power, so that's going to go down below. Now, we are not completely done yet, because always check your numbers. And what about 64 divided by 2? Well, 64 divided by 2, that's a 32. And so that's going to be 32 x to the 30th over y to the 14th power. We do not want any negative exponents. You just simply rewrite it. Let's look at one more of these. And I'll pick one of the harder ones from your homework here, because I did give you some more difficult ones. A lot of it is scientific notation. But let's look at now from your homework, let's look at question 13. I'll leave 14 for you to do, which is, I think, is the easier one. But we're going to look at your homework. (4.1). We're going to look here at question 13. So we're going to go through all the rules, and we're going to see how we apply the rules here. So we've got a 10t to the negative 4th over t squared, all raised to the negative 4th power, times 11 over t to the negative 4th. Okay, so what I always like to do first is parentheses, and that may require the product or the quotient rule inside. So let's take our first step, and let's look inside of our parentheses here. Now, what do we have inside the parentheses? Okay, and this is going to be my work over here. Inside of the parentheses, these t's can go together, and that's going to be t to the negative 4th over t squared. Now, what are we doing? We are dividing, and when we divide, the exponents subtract. So that's t to the minus 4 minus, watch your double negatives here, or sorry, single negative. So we got a 4 minus 4 here, right? Minus 2. And that gives you then t to the negative 6th power. So that is then 10 t to the negative 6th power, all raised to the negative 4th, times 11 t to the negative 4th. So first thing I did was I just combined those together. Now, I am not going to get rid of my negative exponents until the very end. So we're going to keep all of our negative exponents until the end. Let's go to the next step. Okay, what's the next step going to be? Parentheses, order of operations. Remember, parentheses are next. So this gets distributed through. So that then becomes 10 to the negative 4th power. T, negative and negative makes it a positive 24. So t to the 24th power. We still have an 11. And these can go together, right? And that's going to be over t to the negative 4th. Now, we need to break this up as much as we can. What do we know about 10 to the negative 4th power? Well, 10 to the negative 4th power would be 1 over 10 to the 4th power. And what's 10 to the 4th power with our calculator? Let's try that. 10 to the 4th power is, using the calculator here, 10 caret 4. That's going to come out to be 10,000. So that then becomes 1 over 10,000. It's just a matter of working through the pieces a little bit at a time. Now, we still have the 11, right? So that's going to stay. And then we have the 10,000 down below. What about the t part? What do we have for the t part? Well, we have t to the 24th power over t to the negative 4th power. And those can go together as t to the 24th power. Now watch your signs. Minus a minus 4, and that makes that positive. So that's going to come out to then be t to the 28th power. And that's going to be your final, finished answer. So there's very little to work with here. Now let's talk about fractions and how we take powers of fractions and how we work with numbers with negative exponents and how we can combine them together. So this is going to be very, very similar to question 6. Just different numbers. They use some different numbers. I'm going to change them around a bit. So how about we have 3 to the negative 3rd power, and we'll use a minus 5 to the negative 1st power. Now, what we need to do is we need to first do our exponents. Then we can deal with the subtraction. Now remember, what are these going to be? Well, these are negative exponents. So we can rewrite this then as 1/3 minus 1/5, right? Because negative exponents become fractions. So that just becomes a 1/3. That becomes 1/5. Now, if I want to put these together, I need a common denominator. So this one gets a 5/5, and this one gets a 3/3, right? 4 common denominators there. And then what am I left with? Well, 5 times 1, that's a 5. So that's 5/15 minus 3/15, which is then 2/15. And that is very, very similar to question number 6. Different numbers is the only difference. Now let's look at another one. How do we do something like this? This is going to be like question 7. Different numbers is all it has. How would we handle this? Well, the first thing I would do is I would distribute it through. Distribute that negative 2 through. So then we have 4 to the negative 2nd over 7 to the negative 2nd, right? It gets distributed through. Now, what about negative exponents? Well, negative exponents, they switch around. So they're going to switch across the equal bar. So this 4 to the negative 2nd, it goes down below. And this 7 to the negative 2nd, well, it's negative below, so it comes up to the top. So if it's negative on the top, it goes down below. If it's negative down below, it can come up to the top. So then rewriting, that is going to be 7 squared. When it comes up, it becomes positive over 4 squared. And we know 7 squared is 7 times 7, which is 49. And 4 squared is 4 times 4, which is then 16. Now let's talk about scientific notation, the last part of this section. And it's pretty easy. We're going to talk quickly about scientific notation. Now, when we talk about scientific notation, we're talking about either really large or really small numbers. And in many cases, it's easier for us to use scientific notation than to write up a whole bunch of zeros. So I'm going to show you what standard notation is, and then how to convert this to scientific notation, and then back and forth. So let's say I give you the number 105,000. And I want you to convert this to scientific notation. So we're going to convert this to scientific notation. First thing we do is we find our decimal point, which is right here. And then we want this to be one digit. So only one digit and then the number. So here's my decimal. Now we're moving it to the left. So 1, 2, 3, 4, 5 places. So when I convert this, this would then be 1.05. And that's going to be times 10 to the 1, 2, 3, 4, 5 power. How about 97,000? Okay, well, 97,000, here's my decimal. That would be 1, 2, 3, 4 places. So as a scientific notation answer, that would be 9.7 times 10, and we moved 1, 2, 3, 4 places. Next, let's do a decimal. How about, and we'll put a negative in front, how about a minus 0.00073? So I want to write this one in scientific notation. Now, if you move to the right, you're going to have a negative exponent. Same rules apply. We want one digit, one number, and then the decimal. So this is going to go over 1, 2, 3, 4 places. So in terms of scientific notation, this would be 7.3 times 10, and we went 1, 2, 3, 4 places to the right. So that's a negative 4. And don't forget about the negative still in front. So that just comes along with it. Okay, the negative just comes right along with it. Let's do one more decimal, and then we'll go the opposite. Then I'll give you something in scientific notation, and we'll convert it to standard. So how about 0.0049? What would that be in terms of scientific notation? You're going to have to move 1, 2, 3 places over. So that would then become 4.9 times 10. We're moving 1, 2, 3 places over to the third. Now let's do the opposite. All right, now let's go backwards. Let's take scientific notation and let's convert it to standard notation. So I'm going to give you something in scientific notation, and we're going to learn how to convert this to standard. So how about I give you 5.43 times 10 to the 5th power. Well, we have a 5.43, and how many places do we have to move? 5. So here's my decimal. We're going to move it to the right because it's positive when we go to standard notation. So here's my decimal. We go 1, 2, 3, 4, 5 places. You fill it in with the correct number of zeros. So what would that then be? When I rewrite that, that would be 543,000. Let's do another one. And then we'll talk about the applications. I'm going to do one more of these, and then we'll look at our applications. So again, we're going to convert this to standard notation. And how about we do a decimal? How about a minus 0.0063? Oh, wait a minute. I want to go the other way. My mistake. Let me write it in terms of scientific, and then we'll convert to standard. So let me write this right here. Times 10 to the negative third. So let's convert this one. So this is already in standard form, and what would this convert into in scientific notation? Or sorry, convert this from scientific notation to standard form. So we want to convert this to standard notation here. So this is in scientific. So how do we do that? We got to be very careful with the negative exponent. And so we have a minus 6.3 here. Now, how many places do we have to move? We have to move 3. So we're going to go 1, 2, 3 places. We've still got our 0. I always like to begin with the 0 out front, and don't forget about the negative, because the negative just comes along with it. So in terms of standard notation, that would then be a minus 0.0063. You've got lots of applications. I'm going to work out 3 of these. And that's going to then leave you 2 of them for you to do. So let's look at, I'll do 21, how about 23 and 25? That's going to then leave you with 22 and 24 to do. So let's look at 21 from the homework. Now, what we need to do is we need to set these up. All right, they're either going to be dividing or multiplying. And if they divide, the exponents subtract. If they multiply, then the exponents are going to add together. So assume that the volume of the earth is 5 times 10 to the 14th cubic meters. And the volume of a bacteria is 2.5 times 10 to the negative 16 centimeters. If the earth could be filled with bacteria, how many bacteria could it hold? Now let's think about our answer. Earth is a large planet, right? And if we try to fill it with bacteria that's very small, we should get a large number of bacteria. Really, really large number. Why is that? Because we're taking a large planet and we're filling it full of very, very small things. Bacteria are very small, so we're going to end up with a huge, huge number. So that means we should have a really large positive exponent. So let's think about how we would set this up. We're going to set this one up with division. So we're going to divide these out, and we're going to take the earth and we're going to fill it with bacteria. So we're going to take the volume of the earth, and we're going to fill that with bacteria. Now, what's the volume of the earth? Well, the earth's volume is 5 times 10 to the 14th power. Right? That's the volume of the earth. What about a bacteria? A bacteria is very, very small. So that's going to be 2.5 times 10 to the negative 16th power. First thing we do is the numbers. So let's deal with the numbers first. I always like to deal with the numbers. We've got 5. And we're going to have to divide that by 2.5 because that's down below. 5 divided by 2.5, well, that comes out to be 2. And then what about our exponents? Well, just like we would do before, we are dividing. So these exponents are going to subtract. Watch out for double negatives. So that's going to be 14 minus a minus 16. And what do we know about a double negative? Makes it positive. And so what would that then come out to be when we add them together? Well, it's going to be 2 times 10 to the 30th power. And that's going to be the number of bacteria. And that's going to be the number of bacteria that the earth could hold. So if we filled up the entire earth with bacteria, that's how many would be in there. And that makes sense because if I wrote that out, it would have 30 zeros. Huge number. Why? Because you're taking the earth, which is large, and you're filling it with bacteria that is small. So when you do that, you get more out. So always when you work these out, think about the answer. Should the answer be really large or really small? 23. Speed of light is 3 times 10 to the 8th meters per second. How long does it take light to travel? 2.29 times 10 to the 11th meters, and that's the distance from the sun to Mars. Now, if we think about it like this, it should not take light very long to go from Mars to the sun, right? So it should be a fairly small number. How do we find time? Well, we know that distance is going to equal the rate of speed times the time, right? So what does that tell me about time? So that tells me that time, when I move things around, time is then going to be when I divide the distance over the rate. Distance over rate gives you the time. We know the distance. What's the distance? Okay, let's look here. Distance that it has to travel is 2.29 times 10 to the 11th. That's the distance. And our time is 3 times 10 to the 8th. And we want to know how many seconds it's going to take, which it should not take that long, right? Because we know it's not that far for light to go from Mars to the sun. Light travels really, really fast. It shouldn't take that long to get there. So let's go ahead and work with our numbers first. So we have 2.29. We're going to divide that by 3. And 3 places is usually going to be more than enough. So that's 0.763. And then what about my exponents? Well, we subtract 11 minus 8. 11 minus 8, that's a 3. And what would that be when I convert it? How many seconds would this be? Let's make sure we know how to convert this, because this is small enough that we can just convert it here to seconds. And if we have 0.763 times 10 to the 3rd, well, here's my decimal, and I would move 1, 2, 3 places, right? So 1, 2, 3. And so that is 763 seconds. Which is, if you divide out, not very long, 763. Okay. Divide that by 60. See, it's only 12 minutes. So it would only take about 12 minutes for light to go from Mars to the sun. And that makes sense because we know that light travels very, very quickly. And all we did here was we just simply divided. And then we subtracted our exponents. And then how do we convert this? Here's my decimal point here. So we went 1, 2, 3 places over. That gave me 763 seconds. And you can convert that to minutes, and it's between 12 and 13 minutes. I'm going to do 25. And this will be our last question for today. So I'm going to let you out a little bit early, because I don't want to start another section, because we won't be meeting on Thursday. So let's finish up 25. And question 25, we need to look at the debt per person. So what we've got is we've got our national debt of this small country, and I believe that's trillion, so it's 6.4 if you rewrite it, $1 trillion. And the population is 2,315,000. And we want to know the amount of debt per person. Now, per means divide. So we're going to have to take the debt and divide it by the number of people. So, what's our debt? Okay, and we got to make sure we write this. I'm going to rewrite this in scientific notation just to make it easier. So here we go. 3, 6, 9. So that's going to be 6.4 times 10 to the 9th, because we have to convert that. And how many people do we have? Well, let's convert it as well. We're going to go 3, 6. So that's 2.315. And that's going to be times 10 to the 6th power. Write it so it's not crooked here. What do we do next? We just simply divide. So let's go ahead and divide out here. We've got 6.4. We're going to divide that by 2.315. And we'll take this one out 4 places, because we're going to have, well, 3 places is probably enough, I think. So we'll just take this out 3 places. So that's going to be 2.76 if we round 5. So that's 2.765. And then we have 9 minus 6. That makes it a 3. And we want to convert this again. What would this convert down into? We want it times 10 to the 3rd. So we're going to have to go over 1, 2, 3 places. So that then tells you that each person is going to be responsible for $2,765. And that's per person. Now, no class on Thursday, because that is math relays, so we're not having any math classes at all. So no class on Thursday. March 9th. Okay, that's math relays. We're bringing in high school students, so there'll be a lot of high school students on campus next Thursday. There'll be about 250 of them from area high schools, and they're going to compete in math relays. So we're canceling all of our math courses on Thursday, March 9th. All the other classes will be there. So English, history, whatever else you have, you'll have class, but all the math courses are canceled so that we can work with the high school students. Okay. So no math, so no classes on Thursday, March 9th, and then next week is spring break. Just so we know. So just be aware of that. Next week is going to be your spring break. That's why I didn't want to start a new topic, and I